Okay, so for the first one, the square root of 49, that should be 7. So you got a 7 plus 1 on the left side. 7 plus 1, 7 plus 1 is just 8. So the left side is 8. On the right side, square root of 64 is 8. Square root of 4 is 2. So the right side, you have 8 minus 2, which is 6. Well, 8 is bigger than 6. Okay, so we're going to put the greater than sign. 8 is greater than 6. Right, so the first one is A. For the second one, you have 5 times pi. Okay, so you have a 5 times 3.14. The right side, you have a 15. Well, you know 15 is 5 times 3. Okay, so 5 times 3.14 should be bigger than 5 times 3. Okay, because that 3.14 is just a little bit bigger than 3. Okay, so this one should be A also. Okay. Alright, for the next one, what you have here is inside the parentheses, you have a square root of 4. The square root of 4 inside the parentheses, we're going to use PEMDAS here, right? So we're going to do the parentheses first. Inside the parentheses is a square root of 4. Well, you know the square root of 4 is 2. So what you have here is a 2 squared. And 2 squared is 4. On the right side, you have just a square root of 25. The square root of 25 is just 5. So we know then that 5 is going to be bigger than 4. It's going to be a less than 4 is less than 5. This one's going to be B. Alright, the next one, the square root of 20. So let's go ahead and estimate that because we're comparing it to 4.5821. Okay, repeat that with a non-terminating, non-repeating decimal. Okay, so I know that the next lowest square root is the square root of 16. I know that the next highest is square root of 25. So this is between 4 and 5, so I know it's 4 point something. Okay. Alright, so the 20 is closer to the 16 than it is to the 25. It's closer to the smaller whole number. Okay, so since it's closer to the smaller whole number, and I know that 4.5 is right in the middle, it has to be less than 4.5. Okay, so the estimate for this one might be a 4.4. Okay, but it's closer to the smaller one, so it has to be less than 4.5. Okay, so 4.5 would have to be bigger than the square root of 20. So this one would be B. Alright, for number 5, which point is the most accurate graph for the value 70 over 12? Well, we have a number line here. So for the number line, there's 5 and there's 6 on the ends. Okay, so I have 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6. Alright, so we're probably going to have to use long division for this, okay? And remember, for long division, this can be simplified just to make the numbers a little bit smaller. Both of these are even numbers. I can divide both by 2. Okay? Half of 70 is 35. Half of 12 is 6. Okay? So now I got the numbers a little bit smaller. I'm going to use long division. Okay? And get a decimal value. So 6 into 35.00. So I'm going to move the decimal up. 6 goes into 35 5 times. Okay. 5 times 6 is 30. Now I'm going to subtract. 35 minus 30 is 5, and I'm going to bring down the 0. 6 goes into 50 8 times. 8 times 6 is 48. And I'm going to subtract 2, bring down the 0. Okay, so 6 goes into 23 times. Let's go ahead and stop there. I think we have all we need. Okay, because we have a 5.83. If you look at our number line, hey, there's 5.8, there's 5.9. If you want to write in the 5.9, you can. But 5.83 is between 5.8 and 5.9. Okay, so we know this is going to be point D. So for this one, choose point D. Okay. All right, number 6, you have 3.14 plus a 2.1. So I'm going to add this, line up the decimals, 3.14 and 2.1. Let's go ahead and add, and what I get here is a 4. 1 plus 1 is 2. There's the decimal. 3 plus 2 is 5. So I get a 5.24. Okay. Well, there's 5.2. I know this is 5.3. Alright, so 5.24 is between 5.2 and 5.3. So this is B. Alright, for number 7, which point is the most accurate for this? Square root of 12 plus 2. Well, let's estimate the square root of 12. So if I have the square root of 12, the next lowest perfect square is square root of 9, which is 3. The next highest is square root of 16, which is 4. So I know it's a 3 point something. Okay. Alright, so it looks like it's closer to the smaller whole number. Okay. It's only 3 away from 9, and it's 4 away from the bigger 16. So it's closer to the smaller whole number. So, and it's kind of in the middle, so it's pretty close to 3.5. Okay, but it's closer to the smaller one, so we're going to say 3.4 on this. Okay. All right, so I have to add here 3.4 plus 2. Well, 3.4 plus 2 is going to give you a 5.4. Okay. And if you look up at the number line, 5.4, right, that's pretty close to what C is. Okay. So this one is option C. Alright, number 8, 7 over 10 as a decimal. Well, if it's over 10, okay, then you know that there's one decimal place. Okay, so this is 0.7. Okay, if it's over 100, it's 2 decimal places. If it's over 1,000, it's 3 decimal places. If this is over 10, just have the 1 decimal place. Okay, so this would be B. Alright, so 11 over 22. Well, if you had 22 pieces of pizza, okay, and you ate 11 of them, you ate half of the pizza, right? So 11 over 22, the numerator is half the denominator. Okay, so 11 over 22, that's just going to be 0.5, right? This simplifies to 1/2. 11 over 22, 11 is half of 22. So 1/2 as a decimal is 0.5. Okay, so that one's A. Alright, let's go over to the back. Alright, which is the decimal equivalent of 2/3? Okay, so hopefully you've 2/3 has sunk in a little bit. 1/3 is 0.3 repeating, and 2/3 is 0.6 repeating. But we can use long division on this if we need. Okay, so 3 goes into 2. I'm going to put a 0.00, bring up the decimal. 3 doesn't go into 2, but 3 goes into 20. 3 goes into 26 times. Okay, and you notice from your options, the only one that has a 0.6 is option D. 6 times 3 is 18. When I subtract, I get a 2. Okay, 3 goes into 20 another 6 times. 6 times 3 is 18. When I subtract, I get another 2. And if I keep bringing down these zeros, I keep dividing 3 into 20, which keeps getting me the 6. Right, so that's why it's a 0.6 with a line over it. It's option D. Okay. All right, number 11, 1/4. we can do the same thing as we did in number 10 and use long division. Okay. So I'm going to go ahead and do that here, but you should know 1/4. 1/4 is 1/4. Right? One quarter is 25 cents of a dollar. That'd be the 0.25. But we want to use long division. Let's go ahead and do the 4 into the 1.00. Okay. 4 doesn't go into 1, but 4 does go into 10. 4 goes into 10 2 times. 2 times 4 is 8. And when I subtract, I get 2. And I bring down to 0. 4 goes into 25 times. 5 times 4 is 20. And then I get my remainder of 0. There's the 0.25. Alright, so number 12, which is the best estimate for the square root of 80 to the nearest whole number? So it wants the nearest whole number. Okay, so square root of 80. So since it wants the nearest whole number, we don't want these decimals. Okay, it wants the nearest whole number. Alright, so square root of 80 is between the square root of 64 and the square root of 81. That's 8 and 9. Okay, which whole number is it closest to? It's closest to them. Alright, this one, what is the best estimate of square root of 37 to the nearest 10th? And that's 1 decimal place. Okay, the nearest 10th is 1 decimal place. So the square root of 37, the next lowest perfect square is 36. The next highest is 49. So it's between 6 and 7. So you know it's 6 point something. Okay, so it's 6 point something. We're going to cross out the A. We're going to cross out the D. It's either B or C. Right? It's really close to the smaller one. Okay, so your decimal options have to be less than 6.5. So 6.2 is a pretty good estimate of it. Okay. Alright, what is the decimal equivalent of 7 3/4 for number 14? Well, 3/4 you should know is 3/4. Okay, 3/4, 0.75. Right? 7.75. But let's go ahead and use long division here. I know that my whole has to be a 7. Right? So I'm looking at either C or D. Right? B, the whole is 0. A, the whole number there is 8. So I know it's not either of these. My whole number has to be 7. If I use long division, right, I go 4 into 3.00. Bring up the decimal. 4 goes into 30. 7 times 4 times 7 times 4 is 28. 30 minus 28 is 2. Bring down to 0. 4 goes into 20. 5 times 4 is 20. And when I subtract, I get a remainder of 0. There's the 0.75. Okay, so 7.75. Alright, next one. Between which two whole numbers is the square root of 75? So between which two whole numbers? Okay, so the square root of 75. The next lowest perfect square is square root of 64. The next highest perfect square is square root of 81. It is between 8 and 9. Okay, once the nearest whole number, the whole numbers that go with square root of 64, square root of 81 are equal. Alright, what is the decimal equivalent of 23 over 5? Okay, so 23 over 5, let's go ahead and use long division on this one. I have to put 5 into 23.00. Okay. Alright, so 5 goes into 20 4 times. 4 times 5 is 20. 5 goes into 23 4 times. Now I want to subtract 23 minus 20 is 3, and I'll bring down to 0. 4 goes into 5 goes into 36 times. 6 times 5 is 30, and when I subtract, I get a remainder of 0. There's the 4.6. Okay. A number line shows the whole numbers between 0 and 10, which is the most accurate description, where you describe accurate description of where you would plot square root of 46. Well, we have the square root of 46 on the number line. The next lowest perfect square is the square root of 36. The next highest is the square root of 49. So it's going to be between 6 and 7. So it has to be between 6 and 7. So it's not going to be A, it's not going to be D. Okay, so I'm down to B and C. And it's really, Alright, so it's closer to the bigger 49, so you want it to, you would plot it closer to the 7. Okay, so this one will be C. Alright, for 18, the square root of 48. Choose all that applies. So the square root of 48, okay, that's not a perfect square. Okay, so this is an irrational number. Okay, so for an irrational number, remember there are three indicators of irrational numbers. Pi, 3 dots, square root of an imperfect square. So this fits that description. Okay, so this is an irrational number. Okay, all right. We know in this class any numbers that we see in this class are going to be real. Okay, so I'm going to circle real, and I'm going to circle irrational. And then within irrational numbers, for irrational numbers, it can't be anything else other than real and irrational. All right, number 19, we're going to also choose real on number 19. Okay, negative 1/3. Well, negative 1/3, it's a fraction. Okay, fractions, if it's a fraction, if it can be written as a fraction, you know it's going to be rational. So this is real and rational. Okay. All right, now, so definitely know it's not irrational since it's rational. Okay. So if it's an, we had decided it's an integer or a whole. Well, integers and whole numbers, right? When they're simplified, you won't see any fractions or decimals. Okay, so we're not going to circle integer or whole. We're just going to circle real and rational. Number 20, a student divided 6 feet of ribbon into 2 equal parts. So he has 6 feet and he's dividing it into 2 equal parts. 6 divided by 2 is 3. Okay, so 3 is going to be a rational number. Okay, it can be written as a fraction, 6/2. Solve the equation. X squared equals 64. Well, I know that 8 times 8 equals 64. I also know that negative 8 times negative 8 equals 64. So X could be positive or negative 8. Okay, so I want to choose C. What is the best explanation as to why a natural number cannot be an irrational number? Natural numbers have non-terminating decimal expansions. That's not true. Natural numbers, remember, so let's do this. We have real, and then over here we have rational and irrational. Okay, and for irrational, these are the non-terminating, non-repeating, right? There are 3 visual indicators. 3 dots, non-terminating, non-repeating. Pi, which is a non-terminating, non-repeating number, and square root of an imperfect square. Imperfect square. Okay, so those are our 3 visual indicators. Okay, there's 1, there's 2, there's 3. Okay, all right. So rational numbers on this side, right? You can break them up into there's other divisions of them. The first of which is integer, then whole numbers, then natural numbers. Okay. So integers, whole numbers, and natural numbers. Okay. They cannot be irrational. Okay. So over here, if it's a natural number, it cannot be irrational. Natural numbers do not have non-terminating, non-repeating decimals. These three, right? If you simplify them, when they're simplified, no fractions and no decimals. Okay, when they're simplified, you won't have any fractions and decimals. Okay. All right. Natural numbers can sometimes be irrational, but not usually. So natural numbers can never be irrational. So that's not true. Natural numbers cannot be written as a fraction. They can be. Okay. So if it's simplified, for example, 3, right? 3 simplified is not written as a fraction. It's just be written as 3. But you could write it as a fraction. We saw it up here. 3 could also be written as 6 over 2. Okay, so it's not this one. Natural numbers are rational, and rational numbers can never be irrational. D is the one you want to go with. Okay, natural numbers are rational. Rational numbers can never